We are going to take a look at set theory part 1. In today's lesson, we are going to take a look at the number system, the definition, basic notation for sets, what is subset, and what is the union and intersection for sets. So first, let's take a look at the number system. So as we know, we have a lot of different types of numbers existing out there. But how can we systematically categorize them into different types? So at the innermost part, we have natural number, which is 1, 2, 3, 4. And we use a capital letter Z with a plus at the top as a superscript to denote that. What if we add a 0 to the natural number? We got whole number. And we use a capital letter N to denote that. What if we put all the negative numbers to the whole number set? We got integer, which we can denote with a capital letter Z. What kind of set includes all natural numbers, whole numbers, and integers? We got rational number. And the definition for rational numbers is just simply any number that could be denoted as a fraction with the form m over n, with n is not equal to 0 because denominator cannot be 0. And we use a capital letter Q to denote rational number. Opposite to rational number, we have irrational number, which is simply just any number that cannot be denoted as a fraction, such as root 5, root 2, or any decimals that has a decimal places repeats infinitively, like a pi, 3.1415926. And in this graph, we can see the different relation between all these sets we have just mentioned. And what set could be used to include all the rational numbers, irrational numbers, and all these inner parts. We have real number, which we can denote it use a capital letter R. Outside of real number, we have a complex number, but we are not going to talk about that in detail here. We use a capital letter C to denote complex number. Next, let's talk about sets. So what is the definition of a set? Set is just a group of elements. One example could be 1, 2, 3, 4, 5. And there are 5 elements. And another thing I would like to mention here is that the number of elements in a set is also called the cardinality of a set. So this cardinality just means how many elements are there in a set. In this case, there are 5. So we can say, if I say set A equal to this set, we can say the cardinality of A equals to 5. Next, let's take a look at how we can some notations related to sets. So the first symbol is something like a E. It means belong to or is an element of. So we can say 3 belongs to this set, 1, 2, 3, 4, 5, because 3 is a member of this set. Opposite to that, we have a E with a slash. That means does not belong to or isn't an element of. So we can say 6 does not belong to 1, 2, 3, 4, 5, because 6 is not a member of this set. Next, we have something like a reversed E, which means there exists. So we can say there exists a variable K that belongs to 1, 2, 3, 4, 5. So we know for sure that this K is part of this set. So K could be either 1, 2, 3, 4, or 5. Opposite to that, we have a reversed E with a slash in it. it means there does not exist. We can say there does not exist a m that belongs to 1, 2, 3, 4, 5, which means the number that m represents is not a member of this set. So m couldn't be 1, nor 2, nor 3, nor 4, nor 5. The last symbol we should know is a upside down A, which means for all. We can denote like this: for all x that belongs to q, which means rational number. So for all x that belongs to rational number and something else. After knowing the definition of a set, let's take a look at how we can construct a set. So we have two basic ways to denote a set. So the first way, as I demonstrated before, we use two curly braces and just list elements with comma separating them. Very important is that we need to use curly braces. The second way to denote a set is still using curly braces, but we put our variable name here at first, and then we put a slash here. The slash is called such that, and then we put some conditions or restrictions to the variables. Example would be look like this. So set A equal to x, which is our variable name, such that x is greater than or equal to 2 and x belongs to a real number. So if we put it on a number line, we can easily see which kind of numbers are included in this set. So if here's 0, -1, 1, 2, 3. X is any real numbers greater or equal to 2. So any number is greater than or equal to 2 and is a real number would be included in this set A. So this is an example of the second way of notating a set. Next, let's take a look at an example of a set building. So if I say set C equal to x that belongs to natural number, and the restriction or condition of x is greater than or equal to -2 and less than or equal to 7. So if this is the second way of notating a set, what if I want to list all the elements out for set C? What kind of number that is a natural number, which is 1, 2, 3, 4, 5, 6, and so on, and satisfies this requirement. So if I list all the natural number, just list a few, enumerate a few here, 1, 2, 3, 4, and so on. What kind of number in here that satisfies this condition? We can see that -2, but it's not a natural number. So it starts with 1. So 1, yes, 2, 3, 4, 5, 6, 7. Would A be a member of C? The answer is no, because 8 is a natural number, but it does not satisfy this requirement or condition of x. So 7 would not be a member of C. So if we enumerate all the elements for C, it would be 1, 2, 3, 4, 5, 6, 7. Next, we are going to talk about subset. So what is a subset? Subset means a set that belongs to or is included in a parent set. How can we denote this subset? So some notations that we can use to denote a subset would be the following. So the first one would be this. So kind of like this. And this could be read as is a subset of. So if I say, for example, if I say A is a subset of B, this means every element in A is also in B. So like all elements in A is included in set B. There's another very similar symbol, very similar notation, but with a slight different definition. This is read as is a proper subset of. So the concept of a proper subset is a bit harder to understand. So I can say A is a proper subset of B only if, and this is the mathematical definition, only if B contains at least one element that is not in A. What does this mean? This means that the cardinality of B, so like the amount of elements that is in B is greater than the cardinality of A, the amount of elements that contains in A. But for a subset, the cardinality of the bigger subset could be potentially be equal to subset A. So for example, if I have two sets, set A is equal to 2, 4, 6, 8, and set B equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Is A subset of B? We can see that all these elements 2, 4, 6, 8 are included in set B. So we will say, yes, A is a subset of B. Is A proper subset of B? We can see that, we already see that all these elements are included in set B. And set B has other elements here. So like the size of B is larger than size of A. So we can confidently say, yes, A is a proper subset of B. But can we say B is a subset of A? All these elements in set B, some of them are not included in A. A does not include B. So if I draw this diagram, so B is a subset of A implies this diagram. B is a subset of A. A includes B, which is not valid. So this statement is true. Is false. Sorry. B is not a subset of A. Another example can demonstrate the difference between subset and proper subset if I say A is equal to 1, 2, 3, and B is equal to 1, 2, 3 as well. Can I say A is a subset of B? Yeah, sure, because all these elements in A is included in B. But can I say A is a proper subset of B? The answer is no, because for proper subset, the cardinality of B must be greater than the cardinality of A. But right here, B has 3 elements, A also has 3 elements, they are equal. So A is not a proper subset of B. B does not include any other elements except those elements that is exactly the same as those elements that is being contained in set A. So these are the concept of subset. The last concept of today, we are going to talk about the union and intersection of sets. These two concepts are all relationships between sets. So we can combine and manipulate the relationship between 2 or more sets. So the first one is union. So what is union? Union, we can use a symbol U to denote that. So union is an operation which takes 2 or more sets and unities, unites the elements into a comprehensive set. Which means if I say A, set A, union B, which means all elements from set A or and, very careful, here's and, from set B. Which means, sorry, here should be all. Which means if I draw a Venn diagram, here's set A, here's set B, set A, set B. If I would like to highlight the area that represents A union B, what kind of areas would I highlight or use this red pen? It would be everything that is potentially included in these two sets. Anything would be included. So if I list those elements out, if I have set A that is 1, 2, 3, and set B that is 2, 4, 5, then A union B would be all elements that is listed here. So 1, yes, it is listed in A. 2, yes, it is listed in A and B both, but we just need to list it once. 3 in A, 4 in B, and 5 in B. So this would be A union B. So we unite two sets to a whole set. The next concept is intersection. As suggested by the name, the intersection is the element from set A and set B. They need to appear in these two sets at the same time. And the symbol that we can use to denote intersection is a upside down U, which is the upside down version of union. So if I can say A intersection B. So if I put that on a Venn diagram as well, what kind of area would I use red pen to emphasize this time? So what kind of area represents the elements that appears both in set A and set B? It will be the middle part. These elements would appear in set A and set B at the same time. So if a real example would be if set A equal to 1, 2, 3, 4, 5, 6, and set B equal to 2, 4, 6, 8. What would A intersection B be? So what elements appears twice in both sets? So 2 appears twice, 4 appears twice, and 6 appears twice. So A intersection B would be all these elements that appear twice in both sets. I think that's all for today. Thank you very much. Thank you for watching.